Hello everyone, this is Professor Chan for Math 1240 speaking. Today we're going to finish the rest of Chapter 7, which is 7.4, which is what's called confidence intervals. Okay, so hopefully you guys kind of looked at the PowerPoint. I'm going to do some additional problems for confidence intervals. Here's a formula for confidence intervals, if you remember, and this is for proportion. So confidence interval for proportion is the following. It is p hat plus or minus z times square root of p hat 1 minus p hat all over n. Okay. So let's talk about what this means here. Remember, this is what's called your standard error. Okay. And then if you lump the two together, if you do z times SE, so everything in the plus and minus is called margin of error. Okay. Okay. So you can pause this video, okay, to write that down, but I will erase this shortly just because I need room to write this out. Okay. An idea is, so let's talk about this here, right? What's the point of confidence intervals? Okay, so this was explained partially in the PowerPoint, but idea is confidence intervals is essentially, when it comes to proportion, is when you poll people, okay? So let's say you have, you're asking people if they want to vote for candidate A or candidate B, right? And you poll 70, let's say you polled 100 people, 70 of them said they're going to vote for candidate A, okay? Now, the situation at hand is just because 70% in your sample, right, will vote for candidate A does not mean 70% of your population will vote for candidate A, okay? And that's the reason why, right, a lot of times in elections, pollings are wrong, right? So a lot of times in elections, they'll poll people and they'll ask them how many of them are voting for a certain candidate, and then when the actual election happens, right, it's very skewed. It's not the same percentage as they asked in the beginning, okay? And so confidence interval is, a lot of times, is we cannot actually guess the actual percentage of everyone that's going to vote a certain way, but we can do an approximation, okay? And that's called confidence intervals, okay? So in a May 2011 Gallup poll consists of 1,018 adults. Sorry, let me erase that part. 1,018 adult Americans found that 31% believe that gambling is morally wrong. Okay, so let me explain that once again. Okay, out of the 1,018, 31% believe gambling is morally wrong. However, 31%, the percent of people of everyone that believes gambling is morally wrong may not be 31%. So that's the thing we have to realize, okay? This, if you recall, is p hat, okay? Let's talk about this why. Because it's talking about a sample, okay? So, now the nice thing is, confidence interval is really easy to figure out because they literally ask you confidence interval. So they say find confidence interval for proportion. Okay, that kind of gives it away. So you know you're going to use this formula, which is p hat plus or minus z times square root of p hat 1 minus p hat over n. Okay, and what I'm going to do is I'm going to write everything out. So this here, I'll do the p hat 1 minus p hat over n first. So this is going to be square root. My SE is equal to, actually, let me actually write it on the other side. So I have SE is equal to square root p hat 1 minus p hat over n, right? Or in our case, 0.31 times 1 minus 0.31 all over 1,018. Okay, so I'm going to enter this in. And this is 0.0145. Yeah, so we'll go for places. Okay. Now, I want to talk about this quickly. So in the My Math Lab homework, if they say rounded nearest 2 digits, okay, you generally want to calculate at least 3 digits out. So always one more so that you'll round and you'll get closer to your answer. Okay. So if they say round to 2 digits, don't start off with 2 digits. Okay, go out to 3. If they ask you to round to 3 digits, go out to 4 and so forth. Okay. So that's my confidence interval. Now, how do I find my z? So I have this table here. Let me show this to you right here. That if I have a 99% confidence interval, my z is going to be 2.58. Okay, do not worry, you'll get this table. Okay, this is also in your PowerPoint too. Okay, but the idea is you correspond, right, the margin of error to the confidence level, sorry, your z-score based off of your confidence level that they give you. So they say 99%, you're going to start with 2.58. Okay, so this is what we're going to do. We're going to do, so we know that z is equal to 2.58, okay? So I have everything, right? I have p hat is 0.31. I have z is equal to 2.58. And I have my confidence interval is 0.0145. So this right here is pretty easy to plug in. So I just do 0.31, right? And I notice my z is 2.58. And my confidence interval, right? So my standard error is 0.0145. Okay. So we'll enter this in. So I'll do 2.58 times 0.0145. 0.31 plus 0.03741, and then 0.31 minus 0.03741. Okay? So this is my confidence interval. I have, so it's 0.34741. So this right here is my confidence interval. Okay, so let me show you, right? So I added and subtracted, and I get the following here, okay? And you can write it as a percentage. Just be really careful in terms of the homework, what they ask you. So sometimes I'll ask you to write it in a percentage, sometimes I'll ask you to write it as a decimal, okay? Now, they ask you how to interpret this interval, okay? You'll say the following. You'll say, we are 99% confident that between 27.259 to 34.741% of all adults, Americans that are Americans, believe gambling is wrong. Okay. So let's talk about how we construct your sentence. So you say the percent confidence, okay? Then you say, um, what your confidence interval is, right? And then you want to make sure you're talking about everyone. So we're saying my population percentage should be in between those two percentages, and then obviously answer what the question that they're asking, okay, for the following. Okay. Okay. Okay, so let me look at another example. Let's scroll down. Okay. I'm going to actually move this question down. Okay, so let's take a look at number 2 here. Okay, so it says the 18th century French naturalist, he tossed a coin 4,040 times. So we should realize this is n, right? And we got 2,048 heads, give a 95% confidence interval that it lands heads up. Okay, now here's the situation at hand. They do not give you your p hat. However, if you notice, your sample's 4,040 and he flipped 2,048 heads. So your p hat this time is, right, 4,040 is on the bottom because he tossed it 4,040 times and he got 2,048 heads, okay? And you will see this, right? So they may ask you to calculate that out. So you'll you'll take your calculator and divide it by your total number. So this is 0.50, let's do 0.50. Okay, we can do 0.5069. Okay, so I will calculate my standard error, which is 0.5069, 1 minus 0.5069, and I divide it by 4,040. Okay. Okay, so I get 0.00, we'll go 4 places, 0.0079. Okay, so let's look at this right here. So the last thing we need to find is find our z. Now let's talk about this here, okay? So notice it says 95% confidence interval. I'm going to go to my table. Okay. Now here's the thing. You can use either 1.96 or 2. Because if you think about 95% is 2 standard deviations away, right? 68 was 1, 95 was 2, 99.7 was 3. Okay. However, you can do 1.96 as well. Now, when you actually do this on your homework online, they are pretty picky, so I believe you have to use 1.96, okay? Otherwise, you'll be off by a tiny bit and they won't accept it, okay? So, z is equal to 1.96. We'll use 1.96 here. Okay. So we have everything out, right? So my confidence interval, right, is p hat plus or minus se times z, 0.5069 plus or minus 1.96 times 0.0079. We'll multiply it out. Since I'm rounding it to 3, I can round to 4, okay? So I'll just go out to 0.0155. Sorry, 0.158. Okay. Or sorry, was it 5.8 or 5? No, it's 5.5. My bad. Okay, and then take your calculator out and add and subtract, right? So I'll do 0.5069 plus 0.0155, and then 0.5069 minus 0.0155. Okay, so it's 0.4914 to 0.5224 is my confidence interval. Okay, so we write the following: we are 95% confident that all tosses between 49.14 to 52.24% will land heads. Okay? So let's talk about what we want in our sentence, right? We want to talk about the percent confident. We want to talk about the entire population, say your confidence interval, and then what you're trying to find. Okay? So hopefully that kind of clears things up. Okay? Let me just readjust this right here. So the last part of this question says, are you confident that this probability is not 1/2? Okay, so let's talk about this right here. Okay, so we're trying to figure out if it's not likely it's not 50%. Okay, so notice, right? So the idea is my P in this case, which is 50%, is in between, right, 49.14 to 52.24%, okay? You see that so that it is possible. So, okay, for the following here, right? So we would say, no, we aren't, okay, right? So it is possible to be 50%, okay? Because my confidence interval, do you see, it contains 50%. Now, hypothetically, okay? So hypothetically, okay, obviously this has nothing to do with my problem, but let's say my confidence interval was between, I don't know, like 44 to 48%, okay? And if P was 50, we would say, no, it's not. Okay? Because, right, 50% doesn't fall between 44 and 48. So the idea is, remember, the confidence interval essentially is the idea that as your, it's almost a margin of error, right? It's kind of a safety net, right? So a lot of times we'll be like, maybe it isn't 50%, but it could be between 48 to 52, okay? So let me explain this. So if I go back up to the first one, right? So like the idea is like maybe it's not 31%. We might not be completely correct, but we do believe it's between 27 to 34%, right? So that's the idea right there, okay? And then you want to kind of understand this other aspect too, is as your percent confidence goes up, okay, your margin of error will go higher because your confidence interval will be wider, okay? Confidence interval, another way to understand confidence interval is this. Confidence interval, you can almost think of it as percent accuracy, right? So if you say we're 99% confident, we're saying we're 99% likely to be correct, right? Okay, so that's why if you notice, we don't have a low percent confidence interval, right? I don't say I have 20% confidence because essentially I'm saying 80% of the time I'm wrong, right? Or I don't want to say I have like 5% confidence, because that means 95% of the time I'm most likely to be wrong. So if you notice, my confidence interval levels in this table are relatively high, okay? But the reason why my percent confidence is higher is because my confidence interval will be wider, okay? So, like for example, if I have an 80% confidence interval, okay, I'm gonna make this part up. But let's say I have like P is equal to 50, right? If I have an 80% confidence interval, it's very likely I could have something like it's between 47 to 53, okay? If I have a 99% confidence interval, right, I'll be like 43 maybe to 57, okay? So if you notice, as my percent confidence interval gets higher, my interval actually gets wider, because the idea is it's going to catch my guess, right? If I had a guess, it'll be more likely to land in between the one in the 99% confidence interval than in the 80%, okay? So, okay. Last thing, I want to show you how to do this in your calculator. You can also do this. Let me show this to you. You can do second vars. So hit the blue button and hit vars. Oh wait, no, my bad. Sorry, stat, my bad. Let me do this one more time. Stat, and go to test. And you're gonna go all the way down to part A, which is 1 prop Z interval. So you'll hit enter. Okay, so x over x and n, what is that? X is your top number, and n is the bottom number of your fraction. Okay, now if they give you a percent, right? So let's say if they give you, like, example, this problem here, they give you 31%, just write it as 31 over 100, right? So I can do 31 and then 100, and then I can do the C level, okay? And then that will be my confidence level we have is 0.99, okay? And I hit calculate. Oh wait, sorry, my bad. Okay, so let me explain this right here, okay? So let's talk about this tricky one here. So because I give you a percentage, your bottom number is actually 1,018. Your top number, what you'll do is the following. Sorry, let me go back. Sorry, 1 prop Z test. So your bottom number is 1,018. Your top number, what you can do is you'll do 1,018 times 0.31, right? Because if I divide this by 1,018, right, I get 31%. Okay, so let me go back. So 315.58. So 315.58, I believe. Yeah. And then my confidence level is 0.99. I hit enter. Okay, so it looks like I need a round. Okay, so if I hit calculate, okay, notice I have the following. It's a tiny bit off, okay, but it's a little bit more exact. So notice it's from 27.27211 to 0.34675. Okay, now if you want to do this, you need to show me. You need to write down you're doing 1 prop Z test, okay, and you want to write what you have for your x and for your n. So I'll go back here. So you just need to write, if you want to do the calculator version, okay, you can write everything in and you'll get the following, okay? But it is better to show your work just so that if you screw up, I can kind of see where you mess up. Because if you mess up here, I can't track kind of where you went wrong, okay? Let me show you how to do this one more time. For example, like number 2, okay? So if I look at number 2, for the following, right? My fraction is 2048 over 4040, so I'll type in 2048 for x, and then 4040 for n. And then my confidence interval in this case is 0.95. And hit enter. Okay? And that's what you have here. If we compare it, notice it's relatively close. Okay, it's a tiny bit off just because your calculator is a little bit more exact. Okay? So that's it for section 7.4. If you have questions, let me know. Other than that, I'll see you guys later. Just make sure you can post in the discussion board or send me an email. Okay? Talk to you later.